Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. We are in the chapter of trigonometric ratios and we have already uploaded few videos on the concepts of trigonometric ratios. So in this, one of the most important concept is the trigonometric identities and their applications in problems. So in today's video, we will discuss about trigonometric identities and how to apply them in problems, and we will see some of the important models. Okay, so first of all, in this video, we will learn what are identities. Basically, what are identities and how they differ from equations. Next, we will see what are trigonometric identities. And then we will derive what is sine power 4 theta plus cos power 4 theta, sine power 6 theta plus cos power 6 theta, because these are used in many of the problems. If you remember what is the answer for this and this, it would be easy for us to solve some of the problems. Next, and we have some models like if a sin theta plus b cos theta is equal to c, then what is a cos theta minus b sin theta? And at the same time, a plus b is equal to 90 degrees or 270 degrees or any odd multiple of 90, then what is sine square a plus sine square b and cos square a plus cos square b? We should know them because we will use them directly in solving certain problems. Okay, so first of all, let us see what are identities. First, if you see what is an identity, the identity is an equation first of all. But in that equation, LHS will be equal to RHS for every value of the variable. For every value of the variable used in the identity. But remember, the variables will accept only those values which are in the domain of the functions used in the equation. What is the meaning of it? Let us think about it later. A simple meaning of identity, where LHS is always equal to RHS for every value of the variable used in this particular identity. Then such an equation is called as identity. Okay, to understand it better, first let us take some examples of algebraic identities. So the identities which are used more firstly in algebra, what are they? A plus b whole square is equal to a square plus 2ab plus b square. See, for every value of a comma b, a plus b whole square is always equal to a square plus 2ab plus b square. In place of a and b, you can substitute any real number. For example, you can take a as 5 and b as 3. Then a plus b whole square means 5 plus 3 whole square. You will get 64. And if you substitute a as 5 and b as 3 in RHS, RHS also will give you same value 64. So LHS is equal to RHS for every value of the variable used here. So there are some algebraic identities here. A plus b whole squares and a minus b whole square equal to a plus b into a minus b is equal to a square minus b square, or a plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. All these are examples of algebraic identities where LHS is always equal to RHS for every value of a comma b here. So these are algebraic identities. Then what are trigonometric identities? So once again, dear students, in trigonometry also we have many identities. Don't think there are only 3 identities. No, in trigonometry also we have many identities. For example, I have written sin theta into cosec theta is equal to 1. Remember that sin theta into cosec theta is always equal to 1. But one thing you have to remember, what is it? The values of the variables which you take must be in the domain of the function. What is the meaning of it? Someone can say, sir, can I take any value of theta here? Of course, you can take any value of theta, but the value of theta must be in the domain of sin theta and also cosec theta. So in trigonometric graphs, you will learn what are the domains and range of sin theta, cos theta, tan theta, etc. But here, the domain of cosecant theta is any real number except multiples of pi. Okay, any real number except multiples of pi. In theta, in place of theta, I can take any real number except multiples of pi. Okay, so for that particular values of theta, sin theta into cosec theta is always equal to 1. And next, sin square theta plus cos square theta is always equal to 1. for any value of theta, any where theta can be any real number, which means I can calculate sine square 1 degree plus cos square 1 degree even if I don't know sine 1 degree and cos 1 degree. What is it? Sine square 1 degree plus cos square 1 degree is equal to 1. Sine square 45 degrees plus cos square 45 degrees is equal to 1. Sine square 89 degrees plus cos square 89 degrees is equal to 1. So for any value of theta, sine square theta plus cos square theta is equal to 1. Because the domain of sine theta and cos theta are what? Theta belongs to any real number. Okay. So these are some trigonometric identities where LHS is always equal to RHS for every value of theta in the domain of those functions. Okay. So sin theta into cosec theta 1. Sin square theta plus cos square theta 1. Tan theta into cot theta. Few more identities. Tan theta into cot theta is always equal to 1. But remember, theta must be in the domain of tan theta and also cot theta. Okay. Same way, cos theta into sec theta is equal to 1. You list out some more identities which you remember. Okay. So now what are we going to do next means, I will give you the proofs of 3 most important identities. That is sin square theta plus cos square theta is equal to 1. How? Why sin square theta plus cos square theta is equal to 1? Then sec square theta minus tan square theta is equal to 1. And cosec square theta minus cos square theta is equal to 1. Let us see the proofs of these 3 trigonometric identities. They are very simple proofs. The 3 trigonometric identities. The first one is sin square theta plus cos square theta is equal to 1. The second one is sec square theta minus tan square theta equal to 1. And the third one is cosec square theta minus cot square theta is equal to 1. But remember, while using this identity, in place of theta you can substitute any real number, any angle you can substitute. When it comes to sec square theta minus tan square theta is equal to 1, LHS will be equal to RHS for every value of theta in the domain of sec theta and tan theta. And the domain of sec theta and tan theta is any real number except odd multiples of pi by 2. It means that in place of theta, I can substitute any real number except odd multiples of pi by 2. That means I cannot take theta as 1 pi by 2 or 3 pi by 2 or 5 pi by 2 or minus 1 pi by 2, minus 3 pi by 2, etc. So because secant of pi by 2 or tan of pi by 2, these things are not defined. Okay, so please remember this. And similarly, cosec square theta minus cot square theta is always equal to 1, where theta can be any real number except multiples of pi. Because cosecant of n pi is not defined, cot of n pi is not defined. So in place of theta, we will not substitute n pi, multiples of pi, and any other real angle can be substituted. Okay, now let us see first how to prove these 3 identities. For this purpose, let me consider a right angle triangle. So a right angle triangle ABC, right angled at B. And by Pythagoras theorem, if I use Pythagoras theorem, I can say that AB square plus BC square is equal to AC square. Let this acute angle C is theta. Now it's very simple to prove these 3 identities. From here itself, I can prove it. So first, case 1. So let me take case 1. I will divide with the AC square on both sides. In case 1, what I'll do, I'll divide by AC square on both sides. So then what happens? AB square by AC square plus BC square by AC square is equal to AC square by AC square. Now if you observe from the triangle, dear students, AB by AC. What is AB by AC? AB is the opposite side and AC is the hypotenuse. So AB by AC means opposite by hypotenuse, and opposite by hypotenuse is sin theta with square. So sin square theta plus BC by AC. BC is adjacent side, by AC is hypotenuse. BC by AC means adjacent by hypotenuse, which is cos theta with square, and AC square by AC square is 1. So sin square theta plus cos square theta is equal to 1. I have proved it where theta is acute angle, and then you can generalize it. Okay, so this is the first thing. Sin square theta plus cos square theta is equal to 1. So in this proof, I have taken theta as acute angle, but you can generalize it using the previous concepts. okay, of trigonometric ratios of allied angles, you can generalize it. Okay, the first one, sin square theta plus cos square theta is equal to 1. I got the first identity when I divided by AC square on both sides. Now to get the second identity or third identity, so you can do what? Take this equation 1 again. AB square plus BC square is equal to AC square. See, if I divide with AC square on both sides, I got this. Now divide with BC square on both sides. What happens if I divide by BC square on both sides? If I divide by BC square on both sides, then I'll get what? AB square by BC square plus BC square by BC square is equal to AC square by BC square. Now come back to the figure once again. AB by BC. AB by BC is opposite by adjacent. Opposite by adjacent is tan theta with square. And BC square by BC square is 1 equal to AC square by BC square. That means AC by BC is hypotenuse by adjacent. Hypotenuse by adjacent means secant theta, right, with square. And transpose it to the right side, sec square theta minus tan square theta is equal to 1. So this is how I have proved second identity. Now dear students, if I divide with AC square on both sides, I got first identity. If I divide with BC square on both sides, I got second identity. Now you can try this. Take this equation, first equation again, and divide by AB square on both sides and prove the third identity. You can do it. Okay, so to derive the first identity, I divided with AC square on both sides. To get the second identity, I divided with BC square on both sides. To get the third identity, you do it. You divide with AB square on both sides and you can get the third identity. Okay. Now, few important points regarding these three trigonometric identities and how to use them in problems. Let us see it once. So, when it comes to sin square theta plus cos square theta is equal to 1, we know that theta can be any real number, of course. And while using it in the problems, please listen carefully. From here, sin square theta can be written as transpose cos square to the right side, 1 minus cos square theta. So in problems, if you find 1 minus cos square theta, remember it will be useful if you convert it into sin square theta. And at the same time, 1 means 1 square. If you use a square minus b square, you can write it as a plus b into a minus b, which means you can write 1 minus cos square theta as 1 plus cos theta into 1 minus cos theta. So in problems, in trigonometry, in prove that type of model questions, if you find 1 plus cos theta in the question, it might be helpful if you multiply it with 1 minus cos theta. Keep this in mind. Okay. Similarly, if you find 1 minus cos theta, it might be helpful if you multiply it with 1 plus cos theta. Y means 1 plus cos theta when multiplied with 1 minus cos theta, it becomes 1 minus cos square theta, and which becomes sin square theta. This is the reason. Same way, dear students, from here cos square theta is equal to 1 minus sin square theta. And 1 means 1 square. Using a square minus b square, you can write it as a plus b into a minus b. So while solving the problems, if you find 1 plus sin theta, it might be helpful if you multiply it with 1 minus sin theta. The same way, if you find 1 minus sin theta, it might be helpful if you multiply with 1 plus sin theta. Keep this in mind. Okay, now, so it might be. I'm not saying whenever you find it, you do just this. I'm not saying that. It might be helpful. Okay, so remember this. 1 plus sin theta into 1 minus sin theta is 1 minus sin square theta, which is equal to cos square theta. So this is how you can use the first identity while solving the problems. Okay, next, when it comes to second identity, dear students, sec square theta minus tan square theta is equal to 1, where theta can be any real number except odd multiples of pi by 2. Remember this, the conditions, what are theta values, what are possible theta values. Okay, and how do we use it in the problems? Very simple, just follow the previous methods. Sec square theta is equal to 1 plus tan square theta. So whenever you find 1 plus tan square theta in the problems, you make sure that you just remember that you can use sec square theta. 1 plus tan square theta is equal to sec square theta. Same way, take plus 1 left side. And do remember that sec square theta minus 1 is tan square theta. In problems, if you find 1 plus tan square theta, you can write sec square theta. Similarly, if you find sec square theta minus 1, you can write it as tan square theta. So this is one way of using this particular identity in problems. But this is not the only thing. Dear students, sec square theta minus tan square theta is in the form of a square minus b square. Correct or not? And a square minus b square, if you factorize, what do you get? A plus b into a minus b. Right side one as it is. A plus b into a minus b. Because we will use this particular thing in problems. So from this I can say that sec theta minus tan theta is equal to, and if you transpose this to the right side, into sec plus tan becomes 1 by sec theta plus tan theta. So remember this while solving the problems. If you find 1 by sec theta plus tan theta, you can write it as sec theta minus tan theta. Same way, you can keep sec theta plus tan theta left side, and you can transpose sec theta minus tan theta to the right side. 1 divided by sec theta minus tan theta. So please remember that 1 by sec theta minus tan theta is equal to sec theta plus tan theta. So these two are reciprocals to each other. Sec theta plus tan theta and sec theta minus tan theta are reciprocals to each other. So you remember this while solving the problems. 1 by sec theta plus tan theta is equal to sec theta minus tan theta. Similarly, 1 by sec theta minus tan theta is equal to sec theta plus tan theta. This is very, very important. Remember this. The same way, the same thing can be applied for cosec square theta minus cot square theta is equal to 1 also. In third identity, cosec square theta minus cot square theta is equal to 1, right? Where theta can be any real number except multiples of pi. Where theta can be any real number except multiples of pi, right? And first way of using it in problems is what? Cosec square theta is equal to, by transposing it to the right side, 1 plus cot square theta. So in problems, if you find 1 plus cot square theta, you can remember that 1 plus cot square theta is equal to cosec square theta, and you can continue solving. Or take plus 1 left side, cosec square theta minus 1 is equal to cot square theta. I can use it either way. Okay, so remember this, these two. And at the same time, dear students, as we have discussed in previous identity, by using a square minus b square, I can factorize this as cosec theta plus cot theta into cosec theta minus cot theta equal to 1. So from this we can say that cosec theta plus cot theta is equal to, by transposing to the right side, 1 divided by cosec theta minus cot theta. So therefore cosec theta plus cot theta can be written as 1 by cosec theta minus cot theta, and at the same time from here cosec theta minus cot theta is equal to, you can transpose this to the right side, 1 by cosec theta plus cot theta. So these two are reciprocals of each other because the product of them is equal to 1 now. So remember this while solving the problems. 1 by cosec theta minus cot theta is cosec theta plus cot theta. Same way, 1 by cosec theta plus cot theta is cosec theta minus cot theta. Remember this. Okay. So these are the three basic applications of the three trigonometric identities. Now let us see few important points to remember while solving the questions. These are very, very important. If you remember this, you can easily solve many of the questions. I'll discuss some of them on the board now. Like what is sin power 4 theta plus cos power 4 theta, sin power 6 theta plus cos power 6 theta, etc. The first concept to remember under trigonometric identities, dear students, because we will use this directly in problems. There are problems where we use this directly. So if a plus b is 90 degrees, then sin square a plus sin square b is equal to 1, and cos square a plus cos square b is equal to 1. In tomorrow's video or the next videos, we will be discussing the problems. We will be using the concepts to solve the problems. There we will see many problems where this particular concept is used. So remember this. If a plus b is 90 degrees, then sin square a plus sin square b is equal to 1, and cos square a plus cos square b is equal to 1. Let me prove the first one so that you can prove the second one yourself. So what is it? So first of all, let me take sin square a plus sine square b, and I want to prove that it is equal to 1 when a plus b is 90 degrees. See, so sine square a as it is, sine square of, instead of b I can write what, b is equal to 90 minus a, right? So instead of b I can write 90 minus a. And already in trigonometric ratios of allied angles we discussed that sine of 90 minus a is cos a. If you need more clarity in that, please watch the video of trigonometric ratios of allied angles. This is very important and basic conversions. Sin 90 minus a is cos a with square, and already we know that sin square a plus cos square a is equal to 1. So therefore dear students, sin square a plus sin square b is equal to 1 whenever a plus b is equal to 90 degrees. Similarly, you can prove that cos square a plus cos square b is equal to 1. Now dear students, is this true only for a plus b is equal to 90? Not only for a plus b is equal to 90, it is true even for a plus b is equal to 270 degrees. It is also true for a plus b is equal to 450 degrees. It is also true for a plus b is equal to 630 degrees. Do you observe what are these angles? 1 into 90, 3 into 90, 5 into 90, 7 into 90, and so on. So what are these angles? These angles are odd multiples of pi by 2. So in general, if a plus b is equal to odd multiple of pi by 2, whenever a plus b is equal to odd multiple of pi by 2, sin square a plus sin square b is equal to 1, and cos square a plus cos square b is also equal to 1. So this is the first thing that you should remember while solving the problems, because we can use it directly. Okay, so whenever a plus b is odd multiple of 90 degrees, then sin square a plus sin square b is equal to 1, and cos square a plus cos square b is equal to 1. Odd multiple of 90 means it can be positive odd multiple of 90 or it can be negative odd multiple of 90. Okay, so remember this, the first concept. Okay, how to use this in problems we will see in next videos. Okay, now let us go for the second concept. Sin power 4 theta plus cos power 4 theta. What is the formula of sin power 4 theta plus cos power 4 theta? Means 1 minus 2 sin square theta cos square theta. 1 minus 2 sin square theta cos square theta. If you also remember the multiples and submultiples formula which we teach after compound angles, this is also 1 minus 1 by 2 sin square 2 theta. You will learn it later. Okay, so I am not discussing as of now. Just remember that sin power 4 theta plus cos power theta 4 theta is equal to this. And at the same time, sin power 6 theta plus cos power 6 theta is equal to 1 minus 3 sin square theta cos square theta. So these two are very important to remember because we will directly use it in many of the problems. So for now, let us see how to prove these two. Okay, proof. First, let me take sin power 4 theta plus cos power 4 theta. I can write it as sin square theta whole square plus cos square theta whole square. And dear students, we know from algebraic identities that a square plus b square is a plus b whole square minus 2ab. A square plus b square is a plus b whole square minus 2ab. So using the particular identity, here a means sin square theta and b means cos square theta. Okay, a square plus b square means a plus b whole square minus 2 into a into b, where sin square theta plus cos square theta is 1. 1 with square is 1 only, minus 2 sin square theta cos square theta. So therefore dear students, sin power 4 theta plus cos power 4 theta is equal to 1 minus 2 sin square theta cos square theta. So remember this, we will directly use it in problems. You have to remember this. In trigonometry we have a lot more things to by heart. We have to by heart all these things. First of all, we should know how to prove them, and at the same time we must be by hearting them so that we can use it directly in solving the problems. Okay, now let us see how to prove that sin power 6 theta plus cos power 6 theta is equal to this. So to prove sin power 6 theta plus cos power 6 theta, let me take LHS. where sine power 6 theta plus cos power 6 theta is taken, and I can write sine power 6 theta as sine square theta whole cube and cos power 6 theta as cos square theta whole cube. And a cube plus b cube identity, if you remember from algebra, a cube plus b cube is a plus b whole cube minus 3ab into a plus b. You can also use a cube plus b cube as a plus b into a square minus ab plus b square. You can use that also, but I am not using that. I will use this. Okay, a cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b. If I use it, this is in the form of a cube plus b cube, where a is sine square theta and b is cos square theta. Okay, so a plus b whole cube minus 3 into a into b into a plus b. See, sine square theta plus cos square theta is 1 with cube. 1 cube is 1 only, minus 3 sine square theta cos square theta into, this is 1 again. 1 sine square theta plus cos square theta is 1, no? So into 1 is not needed. So therefore, dear students, we have also proved that sine power 6 theta plus cos power 6 theta is equal to 1 minus 3 sine square theta cos square theta. So remember this, we will use these two directly in problems, and in upcoming videos while solving the problems we will see that. Okay, we will see how to use this while solving the problems. You will see it. Okay, next we'll go for, under concept 2, one more important point is that to remember. Dear students, if you consider sine power n theta plus cos power n theta, take sine power n theta plus cos power n theta. Let this is equal to some s suffix n or p suffix n or whatever you want to take. What is the meaning of it? Means here s suffix 2 means sine square theta plus cos square theta. S suffix 4 means sine power 4 theta plus cos power 4 theta. S 6 means sine power 6 theta plus cos power 6 theta. Remember this. If this is equal to s suffix n, then dear students, what's important to remember is Sn minus Sn plus 2. Sn minus Sn plus 2 is equal to Sn minus 2 into sine square theta cos square theta. Or else you can also say that Sn minus Sn plus 2 divided by Sn minus 2 is equal to sine square theta cos square theta. This is always true. What does it means? What does it means I can say that S4 minus S6 divided by S2 is equal to sine square theta cos square theta. I just took n as 4. You got it? S4 minus S6 by S2 is equal to this. I just took n as 4. Okay now. So if you want, you can verify it with the previous formula. S4 means sine power 4 theta plus cos power 4 theta, and S6 means sine power 6 theta plus cos power 6 theta, and this is sine square theta plus cos square theta. Substitute, you will get sine square theta cos square theta. Okay now. Now let me prove that this is equal to sine square theta cos square theta always. So what is it, dear students? If you take LHS here, Sn means sine power 6 theta, sine power n theta. What is it? S suffix n means sine power n theta plus cos power n theta minus of. S suffix n plus 2 means sine power n plus 2 theta plus cos power n plus 2 theta. Let me write Sn minus 2 as it is. I'll use it later. So dear students, using a power m plus n, I can write this as a power n into a power n. A power m plus n means a power m into a power n. So sine theta power n plus 2 is sine power n theta sine square theta. Same way here also I can write this as cos power n theta into cos square theta. Okay. So now the first term is sine power n theta minus this, and next cos power n theta minus this, whole divided by this. What we can do, dear students, in these two we can take sine power n theta common, and if you take sine power n theta common, you will get 1 minus sine square theta. Because I took sine power n theta common in these two terms, I will get 1 minus sine square theta, and 1 minus sine square theta is cos square theta. Plus, and in these two terms I can take cos power n theta common. I'll write it above. Okay, in these two I have taken sine power n theta common. You'll get 1 minus sine square theta, which is cos square theta. And in these two I can take cos power n theta common, and I will get 1 minus cos square theta, which is sine square theta. The denominator is Sn minus 2. Okay, now in the first term and the second term I can take sine square theta cos square theta common. In the first term and the second term I can take sine square theta cos square theta common. So if I take sine square theta cos square theta common, what do we get? If I take sine square theta cos square theta common, cos square theta went outside and sine square theta went outside, and this becomes sine power n minus 2 theta plus. I took sine square theta and cos square theta outside, so this becomes cos power n minus 2 theta. Okay, and the denominator is Sn minus 2. So observe, this is Sn minus 2 and this is also Sn minus 2. Both are same only. They will get cancelled. Therefore, what do we get? We will get sine square theta cos square theta as the result. So therefore, dear students, Sn minus Sn plus 2 by Sn minus 2 is equal to sine square theta cos square theta, where n is greater than or equal to 2 and n is a natural number. I forgot to mention this. So remember this. So therefore, what is the conclusion, dear students? So what is the conclusion of this particular concept here? So we can conclude that if Sn is sine power n theta plus cos power n theta, then we can say that Sn minus Sn plus 2 divided by Sn minus 2 is equal to sine square theta cos square theta, where n is greater than or equal to 2 and n is a natural number. You can use it directly while solving the problems. Okay, remember this. We will use it directly while solving the problems. Next concept. Another important concept to remember, dear students. If a cos theta plus b sin theta is equal to c, if a cos theta plus b sin theta is equal to c, then a sin theta minus b cos theta. What is the value of a sin theta minus b cos theta? Means it is plus or minus root over a square plus b square minus c square. We will use it directly in the problems. How they will ask means, for example, if 3 cos theta plus 4 sin theta is equal to 5, then what is 3 sin theta minus 4 cos theta, they will ask in problems. You can use this formula directly and you can get the answer. But let us see how to prove this. Okay, now, so what they have given here, dear students, they have given that a cos theta plus b sin theta is equal to c, and I have to prove that this is equal to this, right? Let me take this is equal to some constant called k. Let a sin theta minus b cos theta is equal to k, and you have to prove that k is equal to this. The proof will be over, right? So what I will do here is, see, the first equation contains sin theta and cos theta. Second equation also contains sin theta and cos theta. You have to get this idea of using identity. Which one? Sin square theta plus cos square theta is equal to 1. To use that identity, here square should be there and here also square should be there. So for that reason, let me do squaring on both sides. So first equation, if I do squaring on both sides, here you can use a plus b whole square expansion. So what is it? A cos theta plus b sin theta whole square is equal to c square. So expand it, dear students, using a plus b whole square expansion. So a square plus b square plus 2 into a into b. So what do you get? 2 into ab cos theta sin theta, so which is equal to c square. Let me call it as equation number 1. I took the first equation, I did squaring on both sides and I got this. Same way dear students, you do squaring on both sides in second equation and write it here. Second equation you do squaring on both sides. So that means what? Here you are going to use a minus b whole square expansion. So a square plus b square only, but minus 2ab, that means minus 2ab sin theta cos theta is equal to k square. So this I did squaring on both sides in the second equation, I wrote it here. So what am I going to do with these two equations? Listen carefully. What am I going to do with these two equations, dear students? If I want to use the identity of cos square theta plus sin square theta is equal to 1, I should add these two equations. Let me add these two equations. So while adding in these two terms, I can take a square common. When I take a square common, I will get cos square theta plus sin square theta. Same way dear students, if I add these two terms and if I take b square common, I will get sin square theta plus cos square theta. And please observe that here plus 2ab sin theta cos theta and minus 2ab sin theta cos theta, they will get cancelled. And you will get c square plus k square because you added on both sides. Okay now, so this is 1 and this is also 1. So a square into 1 is a square plus b square into 1 is b square, which is equal to c square plus k square. You are determined to find the value of k, correct or not? So you can transpose c square to the left side. You will get a square plus b square minus c square is equal to k square. And from here k is equal to, if you want to find k, take the square to this left side. So you'll get k is equal to plus or minus root of a square plus b square minus c square. So where k is this. So therefore dear students, a sin theta minus b cos theta is equal to k means plus or minus root of a square plus b square minus c square. So remember this, very important. If a cos theta plus b sin theta is equal to c, then a sin theta minus b cos theta is equal to plus or minus root of a square plus b square minus c square. So we will be using these concepts directly in solving the problems. Okay, I'll give you one more concept which almost looks like concept 3, but you can prove it. You can try proving this dear students. If a sec theta plus b tan theta is equal to c, and a tan theta plus b sec theta is equal to p, then you can try proving that a square minus b square is equal to c square minus p square. So remember, here I used sin square theta plus cos square theta is equal to 1. And here you have to think which identity to use. If you think about it, you'll get the answer. Try this and let me know in the comment sections whether you got the proof of this or not. Okay, so in today's video we have discussed about trigonometric identities and how to use that and some of the concepts which we use directly in the problems. Okay, so in upcoming videos we will discuss about the problems on trigonometric ratios. I'll try to cover every possible model from trigonometric ratios which are possible for mains or even advanced. Okay, I'll try to cover every possible model. So if you have understood the concept, do like the video dear students, comment your feedback, and if the video is clear to understand, then share this to your friends, help them to get this video and help me to reach this video for as many as possible. So thank you. I will continue in next video. So this is M Sandeep Kumar.